Stan Gibilisco here to talk for just a moment about the difference between power and energy in electrical systems in particular, although it can apply to physics phenomena such as heating and cooling and all sorts of other devices and systems. But we're talking mainly here about electrical power and electrical energy. Energy is power accumulated over time. So we have the formula E for energy equals P for power times time. We might use seconds for time, watts for power, in which case for energy we would get a unit called joules. A joule is a watt second, and that's the way physicists express it. In your home, though, maybe time is measured in hours, P is measured in kilowatts, so your energy would be expressed in kilowatt hours. Energy is power accumulated over time. Let's just say you have a 24-hour period. Let's just, these are hours. Midnight, starting over here at the left, noon, midnight again. Here's your home, your relative power. Actually, this is your instantaneous power as a function of time. Might look like a graph that peaks sometime in the afternoon and evening. Something like that, maybe. This is the morning when your house husband is home with the kids, but not consuming a whole lot of energy. Then, as the afternoon wears on, the working woman comes home, and the husband cooks supper, etc., etc. You know the drill. I'm just trying to give equal time to equal lifestyles here. Be a little fair. But the amount of power at any given instant in time is a point on this graph. At 11 o'clock, you're using that much power. At 6 p.m., you're using that much power. But energy is the accumulated power over a certain period of time. So the energy that you use, say, from midnight to noon, would be represented as the area under this curve. This energy might be expressed in electrical systems, kilowatt hours. This would be kilowatts, and the time would be in hours. As the day wears on, you use up more and more energy total for that day because this area just keeps getting bigger and bigger and bigger. Power, on the other hand, is the rate at which energy is expended with respect to time. If we divide this formula through by T, we get, and then switch it around left to right, we get P equals E divided by T. So, for example, kilowatts, well, that looks fancy, doesn't it? Kilowatts equals kilowatt hours divided by hours. The hours cancel out. It's kind of a trivial mathematical exercise, but it does show that power is the rate at which the energy is expended. So if we were to graph energy on this thing instead, let me see. I guess maybe I can start all over. Hopefully not erase what I don't want to erase and yet erase everything that I do want to erase. This program has a really weird way of bringing stuff back that you don't want. Let's change this to energy instead of power. And this is still time right along here. So your energy versus time is going to constantly increase because you're using a greater and greater amount of energy as the day wears on. But the power is the rate at which you are using the energy at any given moment of time. So when the curve is nearly flat, you're not uh, you're not using much power. When the curve is really steep, you're using relatively a lot of power. So that's how that works. Power is the rate at which energy is expended with respect to time. The greater the power, the steeper the slope on this curve. You might recognize that slope as the derivative of the function of energy versus time, whereas energy is the integral of the function of power versus time. But that gets into calculus, and I know a lot of you are a little bit intimidated by that. You don't really need to do calculus, though, to realize these two things. Energy is the accumulation of power over time, whereas power is the instantaneous rate at which energy is being consumed at any particular point in time. So hopefully that'll clear up the difference. A lot of people use these two terms interchangeably in qualitative discussions, but that's not the case at all when we get down to the actual calculation and real life situations that power and energy seem to show up in. Stan Gibilisco signing off. Until next time, so long.